As discussed, what we're going to talk a little bit about is the tumor banking initiative we're doing in our partnership with a group called D3B that we'll go over a little bit. So what I consider this is part of the second phase of Corsica. So really the first phase, which I think everybody is aware of, was this initial goal to create this prospective data collection network. And that's a network that has not been created in the sinonasal world, given the scarcity of these tumors, that you really were getting a lot of just single institutions kind of showing what they had. So we are very unique in what we've been doing here. But what we're going to focus here on is a little bit of the second step. And this second step was not only did we want to collect the data that we're doing right now with all our patients, but can we also collect the tumor tissue in all these patients? So that's really what we've started doing, is collecting the tumor tissue. And then ultimately, with that tumor tissue, we're going to analyze the genomic data. So basically, you're going to look through the tumors and see what type of genetics or alterations of genetics they have. And very importantly, we're going to marry that data with the outcomes we're collecting. So that's really the crux of the whole thing. So you're going to see when you look out and read about different companies or institutions doing genomic data sequencing, that the sequencing can be done by all these high-level machinery. The real issue is marrying that outcome. So what a lot of people are missing, or a lot of groups are missing, is you don't know what tumors are doing what. So you can analyze a number of different, like say Snucs, and you know there's a number of differences in their genes, but we don't know what that means. Once you have the outcome data, which patients do better with chemotherapy, targeted therapy, that's where that you can use that outcomes in conjunction with the sequencing. And that's really the big power of what we're trying to do here. So we got, I'm going to say very lucky that we had a unique opportunity with an organization called D3B, and that's based out of CHOP. So CHOP is a Children's Hospital of Philadelphia. So as mentioned, I'm at Penn, so I'm right across the street from CHOP, and I have a lot of colleagues over there. And they have this organization. I just want to review what they're doing and how we were able to work with them. So D3B stands for the Center for Data-Driven Discovery in Biomedicine. It's a translational biomedical research center, and it essentially creates large-scale data with specimen resources and tools to drive treatments and accelerate research, both at CHOP and across the world. So obviously, this is a children's hospital. They were predominantly and are predominantly doing pediatric brain tumors, and they have a huge encatchment area. And essentially, if you look here on the map, you can see that they're essentially through North America, Europe, Australia, as well as Asia, where essentially they have 50 plus academic centers and over 100,000 biospecimens that they're actually collecting. So their big initiative is this Children's Brain Tumor Network. They also have a Philadelphia specific, but these are essentially all these neurosurgeons who are sending all these brain tumors. So from our end, where Corsica fits in nicely is because we have this relationship with them, because sinonasal tumors are a much smaller group, it'd be very hard to develop this infrastructure that they have already. So what we're really able to do is, with our philanthropy, actually get involved with them and essentially piggyback on what they're already doing and jump in and essentially create a biorepository with all the infrastructure that they already have for us. So what does this mean for us? So from a practical standpoint, what does this mean? What this means is we have a discussion with every single patient who has a sinonasal malignancy. And if they consent for the tissue sample, which the vast majority do, just like everybody on this call, we really want to help with treatment of these cancers. And once they consent, we collect the baseline patient information. That's the information that we use for the outcomes data that Dr. Wong already discussed. In the operating room, every one of us, when we're taking out these sinonasal tumors, what we'll do is we'll dissect out a specific specimen of the appropriate size. And we all have research coordinators that we've trained up on this, and they'll actually collect the specimens, and then they're going to package it and ship it to the biorepository bank at the Children's Hospital in Philadelphia. And then once it gets there, they have a very sophisticated system where they essentially process all the samples, put barcodes on them. The barcodes are sequenced to the patient's discrete ID number, and these are categorized for future investigation. So that's what's happening now across all our sites to collect all this information. And this is what we have our most recent collections, and you're seeing a number of the sites. Not all the sites are up and running, and the sites you see with smaller numbers are sites that have kind of come on later on, and are getting the numbers up. Us being Penn, we had this relationship already with the Children's Hospital, so it was pretty quick for us. But essentially, what you're seeing is everybody now is really collecting a number of specimens. And as Dr. Wong mentioned, we now have 167 specimens banked, just 15 over the last quarter. And so that's what we're doing. So about 15 to 20 specimens every quarter. So again, you can do the math, but we're really collecting this aggressively. And this is a very, very unique opportunity. There's nothing like this going on across the world from a sinonasal tumor standpoint. So what are our next steps? The next steps are sequencing these tumors, pairing those sequences with the outcomes data. So if there's one thing you're going to take away from my slides, is that's really the key, is pairing the outcomes data with the sequencing. That's the real power of what we're doing. And then ultimately, at some point down the line, to create targeted therapy. I mean, ultimately, precision medicine is where we need to be. Where sinonasal tumors are behind is because we're a rare disease, and it's harder for us to do. But I think we've really jumped a lot of steps to make this happen. And that's all I have on that topic. If anyone has any questions, thank you.